Today we are working on 11A, which is word problems involving solving multi-step equations. So our content objective is students will be able to solve word problems involving multi-step equations. Language objective is students will be able to write equations from word problems. We're really going to stress on that today. And why am I learning this? Well, it's important for solving real-world problems. So, quick background knowledge. You should remember this from the previous lesson. We were working on multi-step equations. So in this case, we would have combined like terms. Then we would have gotten rid of the constant and then gotten rid of the coefficient to get an answer for our variable. Then here, real quick, what does it mean to justify? It means after every single step, you should be explaining to me what property you use. For example, here we were combining like terms. Here we were using the subtraction property of equality. Here we're using the division property of equality, etc. And what does it mean to check? If you take this value and plug it back into y and evaluate it, if you end up with a true statement, then you know your answer is correct. If you don't, that means something went wrong in your work and you need to look back to see where the mistake occurred. Same thing here. What did we do? This case, from the previous lesson, we're not starting with combining like terms. We're actually going to start with distributing. Once you redistribute, you can then combine like terms, and from there you can get rid of your constant, then get rid of your coefficient, and again you can justify after each step what did you do to get that answer. And in order to check, you would plug 4 in back for k to see if you can end up with a true statement. So look at our first example here. It says Miss Shovel charges her music students $25 per lesson plus a recital fee of $50. You pay the recital fee no matter what. How many lessons did the student take if she paid a total of $75? Well, let's see. Let's go ahead and guess and check. So if she's charging $25 per lesson plus that recital fee of $50, how much would it be for one lesson? Well, it's $25 for that one lesson plus that $50 recital fee. So I'm going to say that's $75. Okay, what about 2 lessons? Because we're trying to look for a total of $175. Well, 2 lessons, that's going to be $50 plus that other $50 for the recital fee. So that's going to give me $100. Okay, still not enough. So third lesson. Third lesson, this is going to be $75 because it's $25 per lesson plus a $50 recital fee. So that's going to be $125. Keep going. 4 lessons is going to be $150. And then 5 lessons is going to be $175. So from guessing and checking, I can say that she took 5 lessons. So real quick, if you look in this section right here, this is the lessons, which is the variable. Why do we call it the variable? Well, it's something that always changes, okay? If you'll notice here, the 50 stayed constant, okay? And that's why we call it the constant. No matter what, it doesn't change, okay? So now let's create an equation for this to see how I would solve it, because essentially I don't want to be guessing and checking every single time, especially when it involves decimals and fractions. So here it means $25 per lesson, so that's what you're multiplying every single time. You're multiplying 25 by the variable. So I'm going to call that 25x, x representing the number of lessons. And then it says plus a recital fee of $50, so plus means obviously plus, and that recital fee is going to be $50, so I'm going to go ahead and put 50. Well, it then says that she paid a total of $175. So notice I'm picking and choosing what I think is important information. So I'm going to say if it's a total of $175, then it must equal, because that word total tells me it should equal $175. Now I just need to piece it together. I have 25x plus 50 is supposed to equal 175. Now what do? Well, first of all, I'm focused on the left-hand side of the equation because that's where my variable is. I'm going to get rid of my constant first. I'm going to subtract 50 from both sides. This is going to equal 0. I'm going to go ahead and put a 0 right here. And now, moving on, that's going to leave me with 25x equals 125. Now you're going to have to get rid of your coefficient. This means 25 times x, so the inverse would be to divide both sides by 25. So this here is going to give me 1. 1 times x is going to leave you with x equals 125 divided by 25 is 5. So notice if we said x represents the number of lessons, I would answer my question is the student took 5 lessons. So notice it's the same answer as before, except now we have a systematic way of getting our answer without having to guess and check. So now let's go ahead and take a look at some of these terms. So I notice I'm multiplying 25 times x because I'm looking for the words per, for each, for every, or other words that can mean that you're going to be multiplying, okay, every single time. So now total is making me think of equals. It should equal that. And here, usually what we are trying to find will also tell you where the x goes. Okay, so keep that in mind. So here, for this problem, let's go ahead and read it out loud. Sam is planning a vacation. He already has $180 and saves $45 each week. If the trip will cost a total of $900, how many weeks will it take for him to save for this trip? So first of all, let's highlight some of our important information. Well, I know that he already has, that he is saving $45 each week. And remember from the previous slide that each tells us we're going to be multiplying. Okay, this is probably going to be our variable. So I'm going to go ahead and make that 45x. Now, let's see. He has $180. So if he has that, I'm going to add that. And then the trip is going to cost a total. Remember that word total makes us think of equals. So it's going to equal a total of $900. So now that I have every single piece of my equation, let's write it into an equation. We have 45x plus 180 equals 900. Now I'm going to go ahead and focus my attention on the left-hand side. I'm going to get rid of the constant first by subtracting 180 from both sides. This will turn into 0, so let me just write that real quick. This is 0, leaving me with just 45x equals 900 minus 180 is 720. Now I need to get rid of my coefficient. This means 45 times x, so the inverse would be to divide by 45. So 45 divided by 45 is 1, so I'm going to go ahead and write 1 here. 1 times x is x, and 720 divided by 45, I'll do the math for you, it is 16. However, remember, you need to answer in a complete sentence. You can't just write x equals 16, because that's not the question. The question was asking how many weeks will it take for him to save for the trip? So you would answer your question as, it took Sam 16 weeks. Okay, so now let's move on to the next problem. Now I want you to go ahead and pause the video and see if you can set this equation on your own. Okay, so now let's take a look to see if you did it correctly. For number 3, it says Carmela wants to buy a digital camera for $192.50. She has $24.75 and is saving $15.25 each week. In how many weeks will she have enough money saved to purchase the camera? So first things first, let's think about our coefficient. What's going to be multiplied every single time? Well, I think it's the $15.25 each week. This each word is giving me that hint that that's probably going to be my coefficient. So I'm going to write that as $15.25 x. Well, what is our constant now? Well, she already has $24.75. That's not going to change. So I'm going to go ahead and say since she has it, it's going to be positive $24.75. And eventually it's going to have to equal the price of the camera. So I'm going to say it should equal $192.50. Now that we have each piece of the equation, let's piece it together. We have $15.25 x plus $24.75 equals $192.50. Same as always, I'm focused on the left-hand side. I'm going to go ahead and get rid of the constant first. So if I'm adding $24.75, I'm going to do the inverse by subtracting $24.75 from both sides. So on this side, those are additive inverses, so that's going to equal 0, which is going to leave me with $15.25 x equals $167.75. But now that I got rid of the constant, the next step would be to get rid of the coefficient. This means $15.25 times x. So the inverse would be to divide both sides by $15.25. Here, $15.25 divided by $15.25 is 1. So I'm going to go ahead and write a 1 up here. So here I'm left with 1 times x, which is just x, but here I'm going to have to divide $167.75 divided by $15.25, and I can tell you that that's going to equal 11. So here, again, I need to actually answer the question. It says, in how many weeks will she have enough money saved to purchase the camera? So I'm going to say it's going to take her 11 weeks. Okay. So now we're going to go ahead and move on to number 4. It says it rained a total of 10 inches in a month. The first day it rained 5/10 inches, then it rained 2/3 of an inch each day after that. For how many more days did it rain? So first things first, I'm going to go ahead and figure out what my coefficient is. In this case, I'm going to say it's 2/3. Why? Because the word each day is generally a hint to me that it's going to reoccur. Okay, so I'm going to go ahead and write that as 2/3 x. Now, what is my constant? What is going to be added or subtracted to this to make up the total? Well, I'm going to say it's the 5/10 inches. And since we're trying to figure out how much rain altogether, I'm going to go ahead and add that. Now, last but not least, since our total is 10 inches, it should equal 10. Now that I have the 3 pieces of my equation, I'm going to piece it together and solve. I'm going to go ahead and get rid of my constant first. It's a plus 5/10. First of all, 5/10 is also equivalent to 1/2. And since I encourage you to convert decimals to fractions, I'm going to go ahead and just subtract a half from both sides. Now I'm left with 2/3 x equals 9.5. 2/3 x means 2/3 times x. So the inverse would be to divide both sides by 2/3. Now here, 2/3 divided by 2/3, it's 1. 1 times x would just give me x here. However, on this side, a lot of my students don't want to take the time to do side work. Please, I highly encourage you to do that because you're less likely to make a mistake that way because you can visually see what the next steps are. Some of you try to do too much in your head and you end up making some minor mistakes that end up ruining your entire answer. You don't want to do that after all of this hard work. So here, let me show you real quick. We have 9.5, which I'm going to convert to 19/2, divided by 2/3. So notice I'm writing it out. Now I'm going to change this to multiplication, so it's 19/2 times the reciprocal, which is 3/2. I can't cross cancel, so I'm going to multiply straight across. I'm left with 57/4. This is an acceptable answer. However, they asked me how many more days did it rain. If you said 57/4 more days, that might sound a little bizarre to someone who is not familiar with improper fractions. So you might want to turn it into a mixed number. So some equivalent answers would be 14 1/4 or 14 25/100. So all of these are equivalent answers. So any of these would work. So again, in order to answer the question, however, I'm going to say that it rained for 14 25/100 more days. But again, those other 57/4 is also an equivalent answer, so it would suffice as an answer. Now, moving on to number 5. It says the sum of two numbers is 180. One number is 18 bigger than the other. What are the two numbers? So first things first, if you have no idea what to do, you don't know how to set up your equation, your best bet will always be to guess and check. Okay, so if you're guessing and checking, you're plugging numbers in, you're trying to figure out what can make this true. Guessing and checking, you're going to find out is not the most effective way to getting an answer. You kind of sometimes just end up need to be lucky, so it's not suggested. But as a last resort, if you're not sure what to do, it's a great way to jumpstart the process. So one quick thing is, again, the variable is something that changes. So here, these numbers are variables because every single time it changed. But again, guessing and checking is not the most effective way, so let's create an equation. First things first, the biggest tip that I can give to you is always assign the variable to the smallest value, whether it's an age, a length, a distance, a number, whatever it is, the smallest value should get the variable. Does it always have to be this way? No, but it's a good way to start. So here I'm going to say the first number is my smallest number, so I'm going to call it x. My second number is 18 bigger than the other, so I'm going to go ahead and put x plus 18. One thing I want to address real quick though is a lot of my students in the past had the tendency of just putting plus 18. This is not acceptable because I don't know what I'm adding 18 to. In this case, you would have added 18 to the original number, which is x. So you need x plus 18. You can't just have plus 18. Now it says the sum of these two numbers is 180. So if I were to add these two numbers together, it should equal 180. So now I have an equation. I just need to simplify what I have. X plus x is 2x plus 18 equals 180. First, you just got to get rid of your constant, leaving me with 2x equals 162. Get rid of your coefficient by dividing both sides by 2, and I'm left with x equals 81. Now the last thing we need to do is make sure we answer the question. It says, what are the two numbers? So the first number was just x. So I'm going to go ahead and substitute in 81 for x. So the first number is 81. Well, the second number is x plus 18. So here, again, I'm going to substitute 81 in for x, add 18, and that's going to give me 99. So my two numbers are 81 and 99. So quick reminder, please make sure you're answering the question and not leaving your answer as x equals 81. Okay, so moving on to number 6. Here it says Eric is 9 years older than Barry. The sum of their ages is 31. How old are Eric and Barry? So again, the first thing that I want to do is highlight the information that I find to be important. First of all, Eric is older, and he's 9 years older to be exact. And the sum of their ages, meaning when I add their two ages together, it should be 31. So now I have to ask myself, how many things are we trying to find? I'm trying to find two things. I'm trying to find how old Eric is and how old Barry is. I'm going to go ahead and put Barry first, and the reason why I'm choosing to do that is because Barry is younger. And again, this is just a tip that I use, and I encourage my students to use because it's very helpful. So Barry is first, but then I also need to find out how old Eric is, so I need to put him down as well. Now, what are we going to do to find the answer? Well, since it's asking for the sum, I'm going to go ahead and add their ages together. So now what I'm going to do is assign a variable to, in this case, Barry, since he's younger. I'm going to call Barry B. And since Eric is 9 years older, that's going to be B plus 9. And again, please make sure that you just don't put plus 9. That's not going to be sufficient. And now, since I know that I'm supposed to add their ages and it's supposed to equal 31, I'm going to go ahead and start from there. Here I'm going to simplify my equation to 2b plus 9 equals 31. I'm going to get rid of my constant, leaving me with 2b equals 11. I'm going to get rid of my coefficient by dividing both sides by 2, and I'm left with b equals 11. So here, b is that friendly reminder that that's how old Barry is. So if Barry is 11, Eric, on the other hand, who is 9 years older, would then be 11 plus 9, which is 20. So here I would say that Barry is 11 years old and Eric is 20. Moving on to number 7, here it says, a cable 101 meters long is cut into two pieces, so that one piece is 33 meters longer than the other. Find the length of each piece of the cable. So first things first, I want to highlight the information I think is important. So first of all, the cable is 101 meters long, that's important. And I know that one piece is 33 meters longer than the other. So now it's a matter of, what am I looking for? How many things am I looking for? I'm looking for two pieces. Piece number 1 and piece number 2. Now the next thing is, what am I going to do to find the answer? Well, first of all, these two pieces will still add up to the original length. So what I'm going to do with these two pieces is add them so that it can equal 101. So you notice I went ahead and assigned piece 1 as x. I'm assuming I'm just going to call this the shorter piece. So the next piece is going to be 33 meters longer than the first piece. So I'm going to say 33 plus x, or again x plus 33, because that's the standard form. And again, please make sure that you don't just put plus 33. That's not good enough. Now I'm going to go ahead and add these together and make sure they equal 101 meters. So now that I've set up my equation, I'm going to go ahead and simplify until I can get what x is. X plus x is 2x, and I'm going to add the plus 33 equals 101. I'm going to get rid of my constant by subtracting 33 from both sides, leaving me with 2x equals 68. Now I'm going to divide both sides by 2 to get rid of my coefficients, and I'm left with x equals 34. Now once again, I'm not done because they didn't ask me what x is. They want to know what the two lengths of the pieces are. So here, piece 1 was x. So all I'm going to do is plug in 34 in for my x value. So piece number 1 was 34. Piece 2 was x plus 33. So here I'm going to substitute my value in for x yet again, and then just drop down the plus 33. So in this case, piece number 2 is 67 meters. So I'm going to go ahead and answer my question and say that the two pieces were 34 meters and 67 meters. Okay. Now we're just going to go ahead and move on to our next example. Here it says the sum of three numbers is 50. The second number is 4 times the first, and the third is 2 more than the first. Find the three numbers. So again, I'm going to highlight the information that I think is important. Definitely knowing that there's 3 numbers this time, and that the sum of them, meaning if when I add them, is going to equal 50. So how many things am I trying to find? 3. 3 numbers. So I'm going to call it number 1, number 2, and number 3. Now, and what are we going to do to figure out this answer? Well, since the sum is 50, I'm going to go ahead and add all these numbers together. So again, I'm going to go ahead and choose which one I think has the smallest value. Well, let's see. Second number is 4 times the first, so the second one's definitely bigger. So right now, first number is the smallest. And then it says the third is 2 more than the first. So for sure, I'm going to say that the first one is the shortest. So I'm going to go ahead and say number 1 is x. Now, the second number is 4 times the first. So I'm going to times 4, but I'm going to times it by the first. So what's 4 times x? Just be 4x. Then number 3, it says the third is 2 more than the first. So I'm going to add 2, but to the first, which is x. So I'm going to say x plus 2. Now I'm going to go ahead and add these numbers together, just make them equal 50. I'm going to go ahead and simplify by combining like terms. 1x plus 4x is 5x, plus 1x is 6x. So I'm going to be left with 6x plus 2 equals 50. I'm going to get rid of my constant first, leaving me with 6x equals 48. I'm going to get rid of my coefficient by dividing both sides by 6, and I'll be left with x equals 8. Now once more, I'm not done. I need to answer my question. The question was, what are the 3 numbers? So I'm going to go ahead and go back to each number. Well, number 1 was x. So I'm going to go ahead and plug in my value, which is just 8. So the first piece is 8. The second piece is 4x. So I'm going to go ahead and plug that in. 4 times x, which is 8. So that's going to be 32. It's going to be a tight fit there. And then number 3 is x plus 2. So I'm going to go ahead and plug in 8 for x. Add 2. That's going to give me 10. So my 3 numbers would be 8, 32, and 10. Okay, now for our very last example. It says here, the perimeter of a triangle is 70 inches. The second side is twice as long as the first. The third side is 5 inches shorter than the second side. How long is each side? So once more, I'm highlighting the information that I think is important. Perimeter, how do we find perimeter? Well, we add all the side lengths together. So that's kind of like sum. Now, I'm going to be focusing on that the second side is twice as long as the first, and the third side is 5 inches shorter than the second. So how many things are we looking for? I'm looking for 3 lengths because we have a triangle. And what are we going to do to find out our answer? We're going to add them because perimeter is basically the sum of all sides. So first things first, I'm going to try to investigate which one's my shortest side. Well, it says the second side is twice as long as the first, so I'm going to say the first is shorter. And the third side is 5 inches shorter than the second side. So here I'm convinced that the shortest side is going to be the first one. So I'm going to go ahead and call that x. The second side is twice as long as the first, so I'm going to times 2 to the first side, which is x, so I'm just going to have 2x. The third side is 5 inches shorter, so I'm going to subtract 5. But from what? Well, it's shorter than the second side, so I'm going to subtract 5 from 2x. So I'm going to put 2x minus 5. Again, since it's perimeter, I'm going to add these three numbers together to equal 70. I'm going to go ahead and combine like terms. 1x plus 2x is 3x. 3x plus 2x is 5x. So I'm left with 5x minus 5 equals 70. I'm going to get rid of my constant first by adding 5 to both sides, leaving me with 5x equals 75. Now I'm going to get rid of my coefficient. 5x means 5 times x, so I'm going to divide both sides by 5. X equals 15, but yet again I'm not done. I need to figure out what these three values are. So I'm going to go back into each individual side in this case. The first side is just x, so I'm going to plug in my value of 15 and say the first side is 15. The second side is 2x. So here I'm going to go ahead and do 2 times 15 for x, which is 30. And then the third side here is 2x minus 5. So I'm going to do 2 times 15 and then minus 5, which would give me 25. So the three lengths of my triangle would be 15, 30, and 25. And there you have it. That concludes our lesson for today. If you have any questions, feel free to email me anytime. Thank you for watching. Bye.